Hello, today we start looking at section 2.4 in Algebra 2, where we will start talking about these things called complex numbers and the operations we do with them. So you can see that the objective is I can solve problems with complex numbers. Today we're going to focus a lot on the skills of what we can do with these things called complex numbers. As an introduction, we want to look at this explore and reason. It says a math class played a game called Solve It, You're Out. At the start of each round, students chose a card from a deck marked with integers from -5 to 5. When an equation is shown, any student whose card states the solution is eliminated. 5 students remain. Okay, so we have these 5 kids left, and those are the cards they have. So again, if you get it right, you are actually out of the game. So the next equation was x squared equals 9. Think for a second about which students would be eliminated and why. When we think about this, we want to think about what number times itself equals positive 9. Well, isn't it true that I could do positive 3 squared, which is 9? So that means Fatima is eliminated. And I could also, though, do negative 3 squared, because a negative 3 times a negative 3 is positive 9. So Mercedes would also be eliminated in that situation. Okay, so Fatima and Mercedes. Now, having said that, in the next round, the equation presented was x squared equals -4. Elijah thought he was eliminated, but that is not the case. Take a look at what Elijah has and explain why he was incorrect. Think about that for a second. Okay, so we can see that Elijah has a -2. So because he saw that x squared equals -4, it made him think that -2 was a solution. But remember, we're thinking about what number times itself gives us a -4. No number times itself gets us a negative, because a negative times a negative is positive, and a positive times a positive is positive. So Elijah actually had positive 4, if we take -2 times -2. Okay, so this is an intro to this idea of x squared being equal to a negative number, which is what our lesson is about today. Now it says, what is true about the solution to x squared equals a when a is positive? Well, when a was positive, a is greater than 0, we got 2 solutions, which were positive and negative the a value, okay? Or square root of a, sorry, positive and negative the square root of a. When a was less than 0, we said we couldn't think of any real numbers that would give us that. So no real solutions. And then if a equals 0, well then we just have one solution, just 0. Okay? Now, having said that, this lesson is about this idea of when a is less than 0, because there aren't any real solutions, but today we're going to learn about how we can still solve those problems. Okay, so solving a quadratic using square roots. This is kind of what we were just doing, but we were thinking about it as what times itself equals 16. The way algebraically we can do that is we can undo the process. So if we have x squared, you've hopefully been taught that you would just square root both sides. So however, I would get x equals plus or minus. So that's that positive, or that situation where the right-hand side is positive. So I get plus or minus, and the square root of 16 is 4. Okay, you don't have to necessarily show all that work for a basic problem like that, but we just want to make sure we're looking at it. Now, if I do the same thing here, I get square root of -9, which is actually, I'd still get plus or minus, but the square root of -9 I can't do. If you type that into a calculator, it's going to say no real solutions. One thing you've learned in your past that hopefully you remember is that you could, though, rewrite this as plus or minus square root of 9 times -1. Which means that I could rewrite it as the square root of 9 times the square root of -1. Now this is making sure you have an understanding of how radicals work, which is kind of a lesson in and of itself, but it is a skill you should have seen in your previous years. Having said that, if I choose to go through this process and break it apart like that, I am left with plus or minus the square root of 9 is 3 times this weird square root of -1. Before I move on, I want to talk about, okay, what is this thing that's the square root of -1? We said we can't have any real solutions. But what this is going to show me, oops, sorry about that, is that we have this new thing called an imaginary unit I. and that is that actually anytime we have this square root of -1, it has us enter this imaginary world, and we can change it to an I. Okay? So if I use that, anytime I see this, I can now take my answer, and I'd say it's plus or minus 3. I replace the -1, square root of -1 with an I. So anytime you have a square root of a -1, you can replace it with this I value. Now, this idea of breaking things apart can go one step further. Let's look at number 3. So I square root both sides. I get x equals plus or minus square root of -72. Now, with what we just learned, we would for sure want to break that apart as the square root of 72 times the square root of -1. You don't necessarily have to show this step. Eventually, you'll just be saying that as soon as you have a square root of a negative, you know it's going to be an I as your answer. But this one has an added step. Okay, so now we look at this 72, and the square root of 72 is not a perfect number, perfect square. So I'm going to think about two things that multiply to get to it, and it's actually 36 times 2. If I break it apart as the square root of 36 times the square root of 2 times the square root of -1, I can actually take the square root of 36, which is just 6. And we actually said the square root of -1 is I. Square root of 2, though, just stays. So this would be the most complex type of problem that you have to do, where you take one number, and not only does it have this new I thing, where I take the square root of a -1 and I change it to an I, but I also have to be able to break the radical apart as two things, one of which is a perfect square. So this idea that you can break apart things under a radical as a multiplication of multiple pieces is going to be important for this lesson. Again, that's a skill you've learned or seen in the past, but it may have been a while. All right, I want you to take a second and pause the video. This one's on the more basic level, but I want you to take a look at this problem, solve it, and see what you get. Okay, so when you square root both sides, you should have gotten plus or minus the square root of -5. When you break that apart, you get square root of 5 times square root of -1. Remember that square root -1 becomes I. We typically put i's in front of the radical so that it doesn't look like it's underneath the radical. And square root of 5 we can't do anything with. It doesn't break apart to a perfect square, and it's not a perfect square. So your final answer would have just been plus or minus I times the square root of 5. Okay, so we introduced that the square root of -1 is this I, but now we have to define that a little bit more deeply. So in math, we have these things called imaginary numbers, and it is any number b times I. So with that I attached, where b is a non-zero real number, and I equals the square root of -1, like we learned. Okay? All right, so now that we know that, we also want to think about this eventually from the other side, and that is if I equals -1, okay, so this is kind of a side note, or I equals square root of -1, if I wanted to get rid of the radical, isn't it true I would just square both sides? So I squared is -1. So we want to understand that for future problems in this lesson, but for the beginning, we started with the radical, and we're converting it to an I. But later today, we'll end up with an I squared, and we're going to convert it to a -1. Okay, so it works both ways. Now, once we understand that these imaginary numbers are things that have i's attached to them, then we also want to understand that we have these things called complex numbers. A complex number is written in the form a plus bi, where a is considered, so a is a real number, b is also a real number, and I, we said, is the square root of -1. But this first part then is considered the real part, and the bi is considered the imaginary part. Okay, it does include all real and imaginary numbers, complex numbers do. What we mean by that is just 5 by itself. 5 is a complex number, so is just 3i. Okay, so it doesn't have to have both parts. So it includes that as well as the sum of the two. Okay, so again, for example, 5 is considered 1, negative 3i is considered 1, but so is 6 plus 2i and 4 minus 3i. Okay, so those would all be considered real and imaginary. Or, sorry, those are all considered complex numbers. Okay, so now that we've laid a foundation of introducing what these complex numbers are, the rest of the lesson is going to focus on mathematical operations with them. The thing I like to think about whenever I'm asked to do adding, subtracting, or multiplying is that it's really just like combining like terms or multiplying with x's. Okay, so adding and subtracting is similar to combining like terms. You're going to add your real parts and add your imaginary parts. So if I ask you to find the sum, remember that's adding. So really I'm taking 4 minus 7i plus negative 11 plus 9i. If I'm adding, I can just get rid of those parentheses right away. But now I'm going to take the 4 plus negative 11 and then the plus negative 7i plus 9i. 4 minus 11 is negative 7. And negative 7 plus 9i is plus 2i. Okay, so you literally just combine the like terms. If they're imaginary, add them together, and if they are the real parts, add them together. You do not have to show the amount of work I did there. That's just to give you a visual. If I ask you to find the difference, we need to understand that means subtract. If you're asked to subtract, be a little bit more careful. I always like to rewrite it as 6 plus 8i minus 2 minus 5i. Now as you get better, you'll just think about it as 6 minus 2 and then 8i minus a negative 5i. And remember, minus and negative is adding. Another option though is to distribute the negative through. So you could do 6 plus 8i and then distribute. I get minus 2 and then a negative times a negative is plus 5i. So you can do that and then do what we did before. Now I'll show you in this case I would do 6 minus 2, which is 4. And then 8i plus 5i is plus 13i. Okay, so there's different ways you can process through these, but you want to make sure that you're combining the real parts and combining the imaginary parts, and just be extra careful if it's subtraction to make sure you apply that negative to both pieces in the second complex number. Okay, go ahead and pause the video. There's a sum and a difference on this slide. I want you to try both. Unpause the video and check your work. All right, so hopefully you, for number 3, got negative 6 minus 3i. And for number 4, you got 7 minus 3i. If you didn't get one of those, you can check my workout on the left to see where you might have gone wrong. Again, common mistakes in number 4 would be we didn't distribute the negative. Okay, last but not least, we want to be able to add, subtract, but we also want to be able to multiply today. Okay, and again, multiplying complex numbers is just like distribution and multiplying binomials. But this is the one time where if you ever have an I times I, we need to remember what we wrote down. And that's if you ever end up with an I squared, it equals negative 1. So you will always replace that. Never leave an I squared in an answer. Okay, so write each product, and we need to remember that product means to multiply in the form a plus bi. So again, for this first one, when I have one thing in front, even though it has an I, I'm going to distribute the negative 2.5 to both pieces. So I would have negative 2.5i times 8. And then I'd have a negative, so it would be plus a negative 2.5i times a negative 9i. Okay, so you don't have to show this step again. I just like to show it when I'm teaching so that you can see what it is. Now when I multiply, I do the negative 2.5 times 8. Type that into my calculator. I get negative 20. Keep the I with it. Negative times a negative is positive. 2.5 times 9 was 22.5. But again, I multiply these numbers, but then I also have to do I times I squared, I times I, which is I squared. Just like an x times x is x squared. Okay? Now is where this comes into play. I have an I squared. I have negative 20i plus 22.5 times negative 1. That is always going to flip the sign. Okay, so I have a negative 20i minus 22.5. And again, usually we write it in the form a plus bi. So we'd usually convert that negative 22.5 to the front minus 20i. Okay, so we do usually put the imaginary part at the end. All right, I want you to maybe try this second one on your own real quick. So pause the video and try that one, because the next slide is the try it, but there's two ugly fractions. So I want you to try number 2 on your own instead. So go ahead and pause the video, try this second one. All right, now hopefully what you recognize is that it's a binomial times a binomial. So we should distribute the 3 to the 3. So 3 times 3 is 9. And then we would multiply the 3 times the 2i, so plus 6i. And now the negative 2i times 3 is minus 6i. And then negative 2i times 2i, again 2 times 2 is negative 2 times 2 is 4. And then I times I is I squared. When I go to simplify, 6i minus 6i is 0. Minus 4, remember I squared is negative 1, which means I have 9 plus 4, which is 13. So it might have been a little tricky to try on your own, but we do want to make sure we understand that idea that if you use the idea of FOIL, you would do that. If you're someone who's used the area model, you could have done the 3 minus 2i, 3 plus 2i. And again, you would have gotten this, which is the same 4 pieces we got here. These would have canceled out, and you would have gotten 13. All right, so here we go. The last slide. If you feel confident with fractions, feel free to pause it and try these. I don't love that they're as complex as they look here, so if you want some help, follow along. All right, so in this first one I would distribute. I would have the 2/5 times 10i minus, because it's a minus, 2/5 technically times the 5/2 I. Now I want to make sure we understand how to multiply fractions. 10 is the same as 10 over 1. Fractions can go top times top, so I'd get 20 over 5i minus 10 over 10i, so I get 4i minus 1. Oh, this was supposed to be an I squared because I had the I times the I, my mistake. Bring that down, minus 1i squared. Don't forget that a I squared is 4i minus 1 times negative 1. Negative times a negative is positive 1, and then we move that real part to the front. So my final answer here would be 1 plus 4i. Now just a quick reminder, just when we were up here, quick trick, 2/5 times 10 over 1. I could have saved some of these steps, so I'm totally fine if you can get to here quicker. One strategy is you can cancel across, so the 10 divided by 5 is 2, so I'd get 2 times 2. And actually when I had the 2/5 times the 5/2, I could see that the 2's cancel and the 5's cancel, which gives me 1 over 1, which is 1. Okay, so you can cancel across like a top on one with the bottom of the other in multiplication. All right, if you feel good about that, try number 4 on your own. If you don't, I'm going to go through it here. This time I'm going to show a few more steps. I do that distribution 1/2 times 1/2 plus 1/2 times negative 2i plus 2 times 1/2 I, and then plus 2 times negative 2, and then I have the I times the I, which is the I squared. All right, 1/2, top times top, bottom times bottom, I get 1/4. This is like over a negative 1, so half of negative 2 though is minus 1, I. 2 times 1/2 is plus 1i, and then 2 times negative 2 is minus 4i squared. These i's cancel out in the middle. I get 1/4 minus 4 times negative 1, which is 1/4 plus 4. Okay, so I could have ended up with 4 and 1/4. It depends if it asked you just to write it as a fraction. Reminder that to take this, I would do the 4 times 4, which is 16 plus 1. This is the same as 17/4. Or I could have gone 1/4 plus common denominator to turn 4 into a common denominator of 4. I get 17/4 that way. So again, flexibility with numbers is going to be important as you go through this course. All right, that's the lesson for today. Again, some review of how to break apart radicals and some fraction work with multiplying and simplifying. But the new ideas are being able to take complex numbers, add, subtract, and multiply them. You can now go ahead and work on your 2-4 day 1 Pearson assignment.